Alright, systems of equations. Up to this point, you've always dealt with systems of equations with linear equations. So maybe it was something like 3x plus 2y equals 8, and 2x minus 5y equals 7. And you had to go through and either use graphing, substitution, or elimination to solve those. And we're doing the same type of problems, except for now we're going to be using equations that aren't necessarily linear equations. So this problem in particular right here has one linear equation and one quadratic equation. So we've still got those same methods available to us. If you could graph it, that would be one method to use. That's going to be kind of difficult at times. And again, graphing is the least accurate out of those three methods. Elimination would work. I've never actually tried using elimination on these, and but substitution. The reason for that is substitution is going to be the most straightforward out of those options. And if you want to try elimination, yeah, try it. Bring it on in. There's no reason why it shouldn't work. You just need to be careful about making sure you didn't combine terms that weren't alike. Now with these equations right here, just wanted to give you a quick visual of what's happening before we get too far along. And so I graphed the two equations, and here they are. Here's the line, the linear equation, the 4 minus 2x equals y. And here's the quadratic equation. Now notice that they're going to touch right here at 2, 0. So that's the solution we should end up finding. Remember, 2, 0, just kind of keep that in your head. And we're only having one solution for this specific problem. It doesn't mean that there's only going to be one solution on these type of problems. For example, we could have no solutions. We might have the line and the parabola never touch. That could certainly happen. You might have no solution. You also could have two solutions. So notice here it's still touching at 2, 0, but now it's also they're also intersecting at negative 2, 8. And who knows where it's at? You could have a large number, you're only going to have two intersections when you have at the maximum, you're going to only have two intersections when it's a linear equation and a quadratic, but it could be all sorts of different points where those 2 points are happening. For again, right now, we only actually have one point of intersection, and it's going to be 2, 0. But let's go through and show that to ourselves using the math. So we'll go ahead and substitute these together. Notice we got y here and y here. So I'm going to plug in 4 minus 2x in for this y right here. And so 4 minus 2x equals x squared minus 6x plus 8. All right, and it's a quadratic equation, so let's get it all set equal to 0. So I'm going to subtract 4 from each side and add 2x to each side. That gives us 0 is equal to x squared minus 4x plus 4, and that's going to factor out to x minus 2 and x minus 2 equals 0. For both of these, the solution is going to be 2, and let's find out where. Now we've got that x value. We've got to plug it back in to for x and solve for y. You can plug it into either equation. I would do the linear because it's just going to be a lot more straightforward and more simple for us to do that. But you would get the exact same y value if you plugged it into the quadratic as well. So we end up with y equals 4 minus 2 times our x value, which we got was 2. If we had two different x values here, we would plug each one in and come up with a different point. I remember in the picture we showed just a few minutes ago, you could have two different points of intersection. I should show you again. You could have two different points of intersection. That would be how that might happen. You'd get a x value of 2 here and plug it in. On this one, get 0, and you'd get a x value on this graph now of negative 2 and plug it in and get 8. Again, that's not our graph right now. We have this situation right here. And we only have one point of intersection, so we only have one x value. All right, but let's go ahead and plug that x value back in. We did, and we got y equals 4 minus 4, so y equals 0. There's our solution, our point of intersection, where do they intercept, and it's at 2, 0. All right, hope that, those pop-ups, hope that helped. Thank you very much.